before we start, you see the screen, right?
Yes, we can see.
Yeah. Hello everyone and welcome to session 5 of the swimming pool design course. So far we have completed 4 sessions already, and today is the last session before the evaluation session or project presentation that's supposed to be done by you. Okay, and I'm gonna talk about how to do your presentation in details at the end of today's sessions. So just bear with me, I will explain everything to you. But the thing, so let's start, and then we will see how you will do your presentation in the upcoming session. We'll discuss at the end. Okay. Uh, so this is our famous agenda, which is our main reference to see how we are progressing in this course. We use it the whole course. Today's topic actually is a continuation for the swimming pool circulation system because we didn't get time to finish the last session. So let's start. Okay. In the last 4 sessions, we learned how to design a service skimmer system completely, right? We have done, we go through all components of the skimmer system. We discuss every single component. We learned what are the function of all equipments, including swimming pool accessories, such as vacuum points, inlets and outlets, skimmers, overflow gutters, and so on. So we learned also how to size pump, the sand filters, the backwash tanks, all types of chemical dosing systems, including ozone and ultraviolet, and also how to do the hydraulic calculation for the supply and the return piping system. So now we are going to see the next type B of pools, which is called overflow system. Okay. So as we discussed in the first session, if you remember, the concept of overflow system is to allow the pool water, okay, to go to the same level of the pool deck here, in the top here, in the same level of the pool deck. Okay, as we see in the picture here, the water collection happening through a drainage channel located around the pool perimeter, which was not the same in the skimmer type. Okay. So the overflow system is mainly used for public pools as it's provide better cleaning for pools water surface because the surface skimmer system is not efficient for the suction of large bodies and not cleaning properly the debris floating in the water surface. Okay, that's why overflow system is much better in terms of cleaning as it provides full coverage to the whole area around the pool. Okay. But we need to know also selecting to use a skimmer or overflow system. Ultimately, it is architecture decision as it is part from the architecture design. But in fact, we need to know the most of WCP projects are having overflow system because it gives like more luxury look and better architecture design compared to the service skimmer system. Okay, if you see most of the new hotels in Dubai today, they use overflow system. Like One Zabil, we have infinity pool in the top of the Link Bridge, and same we have in the Royal Atlantis Hotel, and so on. So all of them using overflow concept today. So the overflow system is the most common design comparing to a skimmer system, but we need to know how to design both of them to be familiar with everything. So we learned the skimmer and we are going to learn today the overflow. Okay. So as we see here in this diagram, we have the same filtration system that we explained in the skimmer pool. We have pumps, we have sand filters, we have heating unit and cooling unit, we have disinfection system, and the good news is sizing those components in the same way of sizing that we learned in the skimmer system. Okay, so the only difference that we need to discuss today is the surge tank. Okay, they call it also the balancing tank. Let's see here. So one of the key difference between the service skimmer pools and overflow pools is the surge tank. Okay, so what is surge tank or balancing tank? The search tank, as we see here in the screen, is this one actually important component in the swimming pool hydraulic system, especially for pools with deck level water like this one, or we call it overflow system. Okay, so in the deck level pools, I need to just open this laser. Okay, you see here the water going to the same deck level around the pool. Okay, so in the deck level pools, the search tank help to ensure that the overflow system, okay, it is collected inside the tank. Okay, the main function of this search tank prevent like fluctuation in the water level and ensure effective pool water management. So this search tank should be designed to accommodate the water displaced by the swimmers, okay, by the waves happening due to wind or by waves happening due to the movement of the swimmers in the pool, and also the cleaning operations, like I'm going to discuss in the upcoming slide, like the backwash and this stuff. So also, we use it to maintain a constant water level in the pool, especially for infinity pools or overflow infinity pools. Okay, and what else? Uh, yeah, this tank, it could be constructed like this, like what we see here, integrated with the pool body, part from this one to built into the pool structure itself and outside the pump room, or it could be separate surge tank, standalone tank located in the pump room, connected to the pool hydraulic system. Okay, so we use the surge tank for managing the water displacement because it is hold the displaced water due to swimmers entering the pool, like those people, and also to prevent airlock in the pump by controlling the fluctuation in the water level and regulating the water flow that entering the pump. Also, we use it for compensate the water losses because it balances the water level by compensating the water losses due to evaporation or splash out, and also the backwash, filter backwash that we explained previously in the session of filter. And we learned also how to calculate the backwash volume because we need it here in this to calculate the size of this tank, as we are going to see. Okay, so a well-designed search tank prevents water level fluctuation and maintain also proper hydraulic efficiency and the proper circulation in the system. So the tank must have three operating levels, as we see here. Okay. First, the maximum water level in the tank here must be just below the base of the channel drain around the pool because we cannot go beyond this one, otherwise it will be flooding everywhere, right? So this level
Okay.
happening, sorry, someone asked? Okay. So this level happening when all swimmers using the pool. So we have the full capacity, all swimmers, the water displaced coming here. Okay, so this volume will be achieved and this level will be achieved. And then the next one, the normal operating level. Okay, here, this level happening when there is no swimmers in the pool, nobody using the pool, just the pool working like circulating to do filtration. Okay, and then we have the minimum level here. Okay, and this level we take into account the volume of water required for filter backwash, starting from the normal operating level here until going to this level. Okay, to ensure that the pumps can still operate without any air going to the pump. So this one, the minimum level, we cannot go below this one, otherwise it will cause like risk of air sucked by the pump. Okay. Okay. So here, actually, I would like to apologize for the quality of this hand sketch drawing, but this is the most accurate sketch describing the search tank details that I found it yesterday while preparing the presentation. Okay. So such level of details, including the additional safeguards of sensors, I couldn't find in any of the project available with me in my library yesterday. Okay. So I got it from the Egyptian code, by the way, page 75 in swimming pool Egyptian code for your reference if you want to go back and check this one. So again, here to maintain the proper operation, some design consideration must be considered in search in the designing the search tank. First, the shape and location, because the tank should be accessible for maintenance and size it to fit within the pump room layout. You can treat this tank exactly like the domestic water tank with slightly difference in the controlling the level as I'm going to explain now. So we have the same like makeup water, we have overflow, we have level sensors, and we have the suction going to the pump, and we have drain in case if we need to drain this tank. So all connections that that we normally use for the domestic water tank is available here. Okay. So what is the difference in this balancing tank? First, we need to consider in our design this space, they call it free port, okay, or the extra height. This space, we use it as a buffer in emergency cases if like all swimmers suddenly jump to the pool. So all of this water go where it's supposed to go to the balancing tank. If this one is not big enough, it will make like overflow inside the pump room and it will be an issue. Okay, so we need to consider this to be big enough. Okay, so regarding to the float valve here, actually this is not the main control to the water getting inside this tank. We are relying in the solenoid valve here, not in this one. We use this one like second protection in case of the solenoid valve is not working. So this one, it will close mechanically. So imagine if the solenoid valve keep open and the water get inside and the water level go high. Okay, so this one we can use it to close the valve. But actually the main control happening due to the sensors and the solenoid valve. And also we have solenoid valve here. This is the suction to the pump, the intake to the circulation pump. We have another solenoid valve here. So how to control those levels? As we just explained in the previous slides, we have three levels, the maximum and the operating one, and this is the minimum one. Once we reach to the maximum, the solenoid valve, it should be normally closed. Also here, okay, once, okay, yes, here the makeup is supposed to start from here, the middle one. The makeup should start from here. Once it go below this one, the makeup start. Once you reach here, it stop. Okay, and this one before the overflow, this it gives alarm actually. This sensor give alarm to the control panel in order to open the solenoid valve in the suction side of the pump here fully to make the pump take more water from here or 100% of the water here more than the main drain coming from the pool. Let's go back. I need to show you here better. So we have the pump here, the suction of this pump, okay, coming from two locations. Actually, this is not the best one. It's supposed to be like drain coming from the bottom of the pool here and to connect it to this one. So we have solenoid valve here. We should have this one connected here with solenoid valve, and here we have solenoid valve also here. Balancing the amount of flow, the percentage of flow between here and here, it should come based on the sensors inside this water tank. If we have the water level go higher than required to the maximum, so we should open this fully and this and close this fully. And once it's go down, we keep opening again to the normal condition in order to ensure we have proper circulation from all drain outs in the pool, from overflow and from here. So this is the concept of controlling the suction side here and the makeup side here. Okay. Any question? Okay. So now regarding to how to size the tank. So the size of the surge tank depends on multiple factors actually, such as the pool size, number of swimmers, the wave action, and the water displacement happening by the swimmers or passers. So we should gather all necessary information in order to do sizing for the tank, such as what is the pool surface area, okay, the surface area of the pool in a square meter, maximum bather load, okay, or swimmer load, they call it bather load actually. So this is the estimated number of swimmers at the peak usage, which is considered usually between 2.5 to 5 square meters. So every swimmer, he occupy around 5 square meter area in the pool. So if we divide the total area of the pool by 5 or 2.5, we will get the bather load. And I will show you how we use this one to calculate the size of the tank. And also displacement per swimmer or bather, the average water displacement per swimmer, which is usually 75 liters per person, as it is written in the screen. Also, the amount of or the volume of water coming from the wave displacement volume. Okay, so we need to consider for the water movement due to waves happening from the wind or the other activities inside the pool. Also, the backwash volume. We can consider the backwash volume part from the tank volume if we are going to use this from the tank. And if we don't have a space, we can also eliminate this one and rely on the water coming from the pool itself, because we have two connections, as I just explained, one from the bottom of the pool and one from the tank. Okay, and we also consider at the end a safety factor to like give some buffer if we have something missing. This it will cover us. So we need to know that there is no recommended formula or equation in codes to size the surge tank. Okay, so I have searched many codes like ANSI, ASB, bridge code. All codes provide only design principle rather than a rigid equation or formula, which is actually leaving a room for professional judgment. You can like estimate that the size of this tank based on the requirement that you have. Like what I just said, if you we need to consider the backwash volume, you will add this to the volume of the tank. If you don't like to consider it, it will be a smaller tank, and you can manage it with the available space based on your project requirement. So the equation used in the screen here, okay, is like combination of empirical data and the recommended percentages found in multiple reference in different design book. So let's see here how to calculate it. So actually we can calculate this tank based on two concepts, whether 50% of the pool volume or based on the bather or swimmer displacement volume, and which one is bigger. We use it to be in like in a safe side. Okay, so this equation here, it is like combination between three things. We are going to show them one by one. First, the volume of the volume displaced by the swimmers or bathers here. So we can calculate this one by, as I just explained, every swimmer occupy like 75 liter of water. So convert this one to meter cube, it will give you 0.075 times the number of swimmers or bathers. We can get this one based on if we divide the area of the pool to the surface area for every individual. So this, it will give me the number of people swimming in the same time, okay, times 75 liter. It will give me the whole volume displaced by the swimmers. Okay, the second one regarding to the waves, search water. Okay, the volume of water coming from the waves. So we can calculate this one by using this equation, the flow rate that we have, the total flow rate of the system, the one that we calculated before in the pump session, and this is the length of the entire channel around the pool, the overflow channel. Okay, so if we have both, we can get the volume of the water surge. And then the backwash, this one, it could be calculated whether like this, 6 times the sand filter area, or we can calculate it based on the 10 minutes duration of the whole flow rate, this one. the one that we use it to calculate the backwash tank, if you remember. So both of them is correct. Okay. So once I calculate step 1, 2, 3, we can get the total volume of the tank. Okay. So we need to verify this against the other way of calculation, the one that I told you, 5% of the whole volume. So we will check which one is bigger. The bigger we will take it and round it up to be in the safe side. Okay. So this is our famous example, the one that we usually use in all session. So our pool here, we need to calculate the surge tank serving this pool. So I put the result here, and I'm going to explain one by one. Okay. First, we need to calculate the water displaced by bathers. Okay. So we have the equation here. We know 75 liter per person times the number of swimmers that we can calculate it based on the area of the pool and the 4.5 square meter, the area by every individual. So the total will come around 2.5 cubic meter. So this is the number that we get. Okay. The second one, the volume of wave surge water, we calculated based on this equation. We have everything, area of the pool, we have the flow rate calculated before, if you remember, in the pump station, it was 75.6, and the length of the channel. So we have everything, we can get the total 1.47 cubic meter, okay? So the backwash, as I just said, we can do it in two different ways, whether by using this equation or 10 minutes of the flow rate of the pool. Okay, both of them is correct. So we used here the new way, which is 6 times the filter area. It gives me 15 cubic meter. Okay, so we have now the three volumes that we need to consider to size our tank. If we sum all of them, we'll get this one like that. Okay, 18.97. Okay, so now the next way of calculating 5% of the total volume. When we calculate this one, we found 15 cubic meter, which is less than the 18.9. So to be in safe side, we are going to use this one, and better to round it up to become 20 cubic meter. So for our pool in this example, we need surge tank with 20 cubic meter. Okay. Okay. So now we finish the overflow. Regarding to the other, the same way of sizing, like heater, pump, filter, the same concept that we follow in the skimmer, it will be applicable here as well. So now we finish the overflow and the skimmer, and now I'm going to show you some projects. Okay, and while I'm searching yesterday, actually, I found this example, which is wrong. Actually, we should not do like that. So I found it worth to be shared with you to explain to you what is wrong happened here in this project. So this is a real project. I don't know how they applied, but this is wrong actually. We have in this project like a main pool for adults, and we have children pool for children. And if you remember, when we calculated when we learn how to size the filter and the pump, we have different turnover rate for different type of pools. The children pool supposed to be something like 2 hours, okay, and this one it could be for 6. So this different than this, it cannot be combined together like that. Okay, in order to maintain the recommended turnover as per the code, we have to make it in a separate circulation system. It should not be combined together, going to the same filtration system and same dosing chemical dosing system, same pumps, same balancing tank, and going together. So this wrong. Do not do like that. Guys, if you have any question, raise your hand. Okay. Okay. So this one, this is schematic actually. Just wanted to show you like summary of what we learned. And believe me, this is one of the most typical piping arrangement that you could need to apply in around 90% of the projects, unless if you have a special client requirements. So we have here overflow system. Okay, most of the projects today overflow system. We have a surge tank. Okay, uh, one of the things I forget to tell you about the surge tank, you need to provide here non-return valve. Okay, this is very important. In the, I mean, the intake of the pumps here, you need to provide non-return valve, because usually this pipe in a level lower than the pool level here, so the possibility of the water to make shortcut from here to here is very high. You know what I mean? If the pump stop and stuff like that, so the water could make shortcut and go and overflow from here. So we need to provide here non-returnable to ensure this one only in one direction. Okay. So again, as I told you, we have here overflow. Okay. As a balancing tank or surge tank. We have backwash tank. Not all projects having the same one. Here we have backwash tank, and we learned how to calculate this one. Ultraviolet, okay, unit. It could be also ozone instead of ultraviolet. Uh, Chlorinator, and we use chlorinator here after ultraviolet. If you remember in the sterilization session, we discussed the ultraviolet doesn't give you residual chlorine. It just kill the microorganism and the viruses passing through this unit. But once you go out, if there is any like potential viruses or microorganism, we need residual chlorine. So we cannot eliminate the use of chlorine, but we will minimize the use of chlorine if we used ultraviolet or ozone. Okay. So we have also pH, it's called pH adjustment system, okay, to maintain the level of pH. And we know how the pH is important, as I explained previously, okay. So this arrangement is the most typical one that you might see in all projects, unless if we have special scenarios, like what I'm going to show you in the upcoming slides. Now, the last thing we need to consider about the equipment arrangement and pump room in general, we need to consider the mechanical room should be accessible definitely and have enough area for all equipment, and the room level should be lower than the deepest point in the pool. Okay, so this is one of the requirement all architecture should be aware about it, and you need to double check once you start in a new project. The level of the equipment room, it has to be lower than the lowest level here in the basin of this pool. Okay. And one more things, if you remember, I told you the chlorine could be gas. Okay, if we are like if for any scenarios required from you to use a gas cylinder, you know, it is toxic. It has to be treated carefully. So we have to assign separate room equipped with proper ventilation system to ensure this not causing any risk to the people outside. Okay. And even inside this room, if we are not going to use gas, we have to provide also like fan, exhaust fan, some proper ventilation. Okay, no problem. Okay, so now I'm going to discuss with you 4 projects. We will go through them to see what is the function of all equipment, including swimming pool accessories such as vacuum points and everything. Okay. Uh, but before closing the PowerPoint, we need to discuss about the presentation, your presentation. Okay. So what I'm going to do actually, you see this example here. I'm going to do, guys, all of you, I need you to just interact with me because I'm asking about your opinion about this upcoming session. So I'm thinking in 2 different ways. Okay. First, whether like dividing you to groups, like 5 groups. Okay. or 4 groups. It depends on the registered people. I will send you form. I will see the total number. Then I will divide you by groups, and the project will be something like that. I will tell you I need to design like public swimming pool, private swimming pool, fountain, whatever. I will show you the fountain, how it work, pond, whatever. So I will tell you I need you to calculate the 10 to show me the 10 over rate, the pump flow and the head, sand filter and the filtration capacity. All what we learned, it will be like bullet points, needs to be calculated by you and presented in PowerPoint. Okay, so this it could be done in 2 different ways. Whether all of you can do in one big project, okay, and you agree together which one will present which part exactly. Let's say we have like 15 points. Yeah, Giovanni.
Quick one. I need to drop into a quick call. There's a team leader call happening now. I need to join. I'll just put a few comments on the chat. Yeah, there's a few more, but I'll catch you separately on that. Yeah, but in the meantime, if you can go through those quotes. I missed the previous session as well, so I'm not sure if those are covered or not, but I'll loop you in separately. Yeah, we're doing a bit more in terms of design perspective, what we can do more internally. So at some point we want to kind of again, Hani is leading that. Hani and forgot her name now, another lady, where we're going to try to do more design in-house. But again, that's not to do with this year, it's to do with next year 2026 initiative, yeah, where we're going to get somebody in-house, yeah, to help us to do the design. Instead of getting a specialist, we'll get the specialist in-house moving forward. Yeah, so that's been happening in the background. But yes, obviously we need to upskill ourselves in terms of you know, design, supervision, authority submission, different types of polls, etc.
You know, all materials that I provided in the previous sessions already saved in the career and the learning portal.
I'll catch you later. I need to drop another call. But okay, thanks. That's nice stuff. Thank you.
Yeah. Thank you.
Bye.
Bye. Okay, guys, you hear me? I believe I have issue with the internet here. You hear me, guys?
Khalid.
You hear me? Someone talking? You hear, but okay. Guys, I cannot hear you. And if you have any question, please write it in the chat, and I will reply back to you. Okay?
Hi, Khalid.
So thank you. You can leave now.
Hi, Khalid.
Thank you so much.
Thank you so much, Khalid.
Thank you, Khalid.
السلام عليكم انجينير خالد. اسمعني يا مهندس خالد. السلام عليكم.